Okay, so we're going to talk about Pascal's triangle and this idea of n choose r, which comes from probability. We're not going to do a lot with the probability, but I'm just going to show you what n choose r means so that you can use it actually for our binomial expansion. So the whole point of this, doing these two little things, is to get you ready for our binomial theorem, our binomial expansion. So that's what we're gonna do. We're just gonna do enough to be able to do that, okay? And then the next video, we'll actually do some binomial expansion, all right? So the first thing we're gonna talk about is Pascal's triangle. And again, you may have looked at it if you've done things like probability or whatever. I'm just gonna show you how to set up Pascal's triangle so that you'll be able to use it when you are doing the next component, okay? So Pascal's triangle is this idea that looks like this. You're always going to start with 1, and then the outsides of the triangle, we're going to draw a triangle with numbers, and the outsides of the triangles are always 1s, okay? So I have 1, 1, 1, and I'm going to make like a pyramid. So the next one, I'm going to start with a 1, and then the next one, what I'm going to do is I'm going to add together these two, and I'm going to get a 2, and then I'm going to end it with a 1. Now my next row is going to have, more numbers in it, but I'm going to start with a 1, and then I'm going to add these two and get a 3. And I'm going to add these two and get a 3. And then I'm going to add the 1. So we are always adding 1s onto the front and the back. And then the ones in the middle, you're just adding these 2 1s that are on top. So 4, 6, 4, 1, and you're going to get this symmetrical looking thing where it's going to be, I forget, there's a name, a palindrome, I guess. They're going to be the same whether you flip it this way or this way, right? You see how it goes up and down. And again, you can start to do these quickly. It's not hard to do. Okay, so this, you're going to need to be able to do this. So this is how we're going to create Pascal's triangle. And you can do this as many rows as you want. You can keep doing this. You can see quickly that this gets like really big or whatever. So another way to find these numbers on Pascal's triangle is to do something called n choose r. Now again, if you're talking about probability and you've seen this before, it looks like this. It's called n choose r. And what it means is if you have a certain number of things and you're going to choose a certain number out of that bunch, how many ways is there to make that happen? So for instance, if I have 20 students and I want to pick 5 for, I don't know, student of the month, right? Now if I said that Jenny, Paul, Tanisha, Bobby, and Larry, right? These are the 5 students that I'm going to pick. It would be the same thing as saying them in this order. It doesn't matter which order I say them in. So this is like picking 20 students and picking 5 of them. These 2 options would be the same. But if I picked instead Jenny, Paul, Tanisha, Bobby, and Maurice, well, that would be a different group. So this group and this group would be different, but these 2 groups would be the same. So it's how many different groups can I get out of the 20? That's what this thing is telling me, okay? So that's what we're going to be looking at. We're going to be looking at how many different groups we can get. Now, this is helpful, again, when we do our binomial expansion. I'll explain a little bit more in that video why this is helpful in that. But let's just take a look at how to do this. So if I had 20 students, if I had 20 things, 20 people, and I wanted to pick 5 of them, this is how we would write it. And we say 20, choose 5. Now, in probability, you probably know there's also permutations. This is a combination. There's also permutations. So where this and this would be different ones, and that's a different symbol. That would be a P here. So the C means that order doesn't matter. Okay, so if you're thinking about your probability, okay? So this formula for this is this guy right here. And again, I'm going to show you how to do it by hand, and then I will show you how to do this on the calculator. since most of you will probably be using calculators when you do it. Okay, so let's look at this guy. So what does this little symbol mean? Reread that one. N is n factorial. And what that means is, like, if I have 5 factorial, that means 5 times 4 times 3 times 2 times 1. And you can probably figure out what 6 factorial would be. 6 times 5 times 4 times 3 times 2 times 1. So it's all the numbers, the integers from that number down. So if we're looking at this guy and we're trying to do 20, choose 5. Okay, that's going to be 20 factorial over n minus r, so that's 15 factorial because it's 20 minus 5, times 5 factorial. Now this seems like, oh, how would I ever do that by hand? But actually, you can kind of simplify this up a bit. So I'm going to think about this as 20 times 19 times 18 times 17 times 16 times 15 times 14, all the way down, right? I'm not going to write them all out. Now down here, this would be 15 times 14 all the way down, right? And then it would be 5 times 4 times 3 times 2 times 1. Okay, so take a look. If you're taking a look at this, and I group it this way, this is 15, 14, all the way down to 1. So is this. And they're all multiplied together, which means I can actually just reduce those or cancel those out. Does everyone see that? So I only need to keep to 16 because 15, 14, these guys are going to make a 1. You're going to reduce these and make a 1. So I've already reduced those out. Then I can start reducing this stuff, right? This right here is a 20, isn't it? So I can reduce the 20. 3 goes into 18 if you want. You can start doing some of that stuff, and you can kind of see that you can kind of reduce these a little bit. So now it's 19, 17, 16, and 3 on the top, and just a 1 on the bottom. And again, it's not ideally what I would love to do by hand, but it's definitely doable. And again, if I have my calculator, it's even easier. So it's 19 times 17 times 16 times 3. And if I reduced everything right, this should be the right number. So that means that there would be 15,000 different groups of students that I could put together out of 20 if I was only picking 5 of them. Okay, now here's the thing. On your calculator, you probably have, you're able to do this. So what I'm going to do is I'm going to hit my little stat button. And I'm going to go over to, is it stat? Oh, I always pick the wrong one. Is it list? Why do I always pick the wrong one? I thought it was under, oh, I know why. Because it's under math, and then it's under probability. I always think it's under statistics because I think of that as having the probability. All right, so it's under math. So I hit the math button, and then I scrolled over to probability. So again, if you can't find it, do what I did. I just played around till I saw it, right? Or the other thing is you can go to your catalog down here. You do your second catalog, and you can scroll down to the ends or type in an N, and we'll put you down there so that you can find the one quickly that you're looking for if you really can't find where it is. But there it was. And it also has factorial. So do you see that? So again, I could type this in. So let's do it this way, and then I'll show you how to use that guy. So I'm just going to quit. Let's clear this out. So I'm going to do 20, and I'm going to hit the math, and I'm going to scroll over to probability, and I'm going to do this guy. And then I'm going to do divided by, I'm going to put it in parentheses, 15 math, this one, times 5. This one. And let's see if I got the right number. Okay, so I feel pretty confident that I divided it properly. See, we got the same number. Now, the other way to get the same thing is the calculator already has the formula plugged in for you. And again, if you know how to make a little program on your calculator, if you can always add little formulas. Oh, sorry, that's not what I wanted. So what do I want to do? I want to put in the 20. Then I want to hit the math button and go over to probability. Oh, but I don't want to pick the first one. I'm having a bad calculator day. So then I want to go down to N, choose R, not the NPR, that's different, N, choose R. So I put in the 20 because you see how the N is in front, so that's going to put it in for the N. Now I have to put the number I'm going to put in for the R, and that's a 5. Okay? Now what this number will do is, so for instance, let's say we have this row right here. Okay? So this is like the 1, 2, 3, 4, well, actually, this is 0, 1, 2, 3, we'll say 4. Okay. So this is the 4th row. Oh, sorry, you can't see it because I did it. So this is like 0, the 0th row, 1, 2, 3, 4. This is how I think about it anyway. Okay. So if this is the 4th row, these numbers are kind of like the numbers N, choose R. So this first one would be 4, choose 4. So if you had 4 people and you needed to pick 4, how many different ways could you pick 4 people? Well, there would be only 1, right? And the next one is 4, choose 1. If you had 4 people and you only needed to choose 1, and it's, I don't know, B, L, T, J, we'll just use the same number, the same people's names. So if I could pick this person or this person or this person or this person, so there'd be 4 ways to do that. Right? So these numbers are actually the same as these numbers when you do this choosing thing. So if I did 4, choose 2, I could have BL and BT and BJ, right? Or I could have LT, LJ, or I could have, LJ is the one I didn't write, or LJ. So I could have 6 different choices. Okay, so these numbers on this thing are the same as this. So take a look. If I'm going down to the 4th row and I have 4 and I'm choosing, well, we'll choose 1, 2, 3, well, that's, 1, 2, 3, 4. Oh, actually, I guess this is, I'm sorry, I did it backwards. It's 0, 1, 2, 3, 4. I think of it this way. Actually, I guess either way, it doesn't matter. You could do it 0, 1, 2, 3, 4, or 4, 3, 2, 0, but I think this way is easier to think about it. So this would be 0, choosing 0. So again, if you have 4 people and you're choosing 0, how many ways can you choose 0? Well, only 1. Only 1. Don't pick anybody, right? So that's this one here, and this one's this one here. So I guess it's semantics, but I think it makes more sense to do it in this order, right, than to do that one as the first one. Okay, so here we are. We got math, and we're going to do, oh, again, I didn't do it right. We're going to do 4, and then I'm going to hit math, and then we're going to do 3, and we're going to pick, well, we'll do this one, 3. And there, it's a 4. And down here, this would be the 5th row. So this would be 0, 1, 2, 3. So let's do 5, math, probability. Choose, what did I say? 0, 1, 2, 3. And you get a 10. Okay, so this is another way to find the numbers on this if you don't want to write out the whole triangle. So again, if you really needed to make the, 8th row or something for some reason, so you know that it's 1, 8, right? So this is 8, choose 0, 8, choose 1, and you could just go across and do 8, choose 8. Oh boy. Nobody's going to watch this anyway. I already know nobody's watching. So 8, choose 2, and you can start to see what they are. And you could actually make the whole row if you needed to. Okay? So that's another way that you can go. And of course, you're going to end with an N, 1. And of course, that would be like 8 choosing 8 people. There'd only be one way to do that. So that's how we can use this N choose R to kind of help us come up with Pascal's triangle. I'm going to use Pascal's triangle to do our binomial expansion. So that will be in your next video.